My name is Kelly Powell, Technical Manager for Invino Engineering, LLC, located in Tampa, Florida. We're a domestic and international engineering firm specializing in steam systems. Today, I'd like to talk about steam performance balancing, really the first step in steam system management programs. First thing to ask is, what is steam performance balancing? Steam performance balance is always the first step in any steam optimization and management program. Efficient way to gain knowledge in the steam generation side, distribution, end users, and condensate recovery systems. Creating and maintaining a steam balancing program, performance balance program, is a continuous process. The thing with the steam balancing, performance balancing example here that we show here is a one-page, or it could be two-page, diagram showing the complete steam system from the beginning, from the users right here, or the generators right here, or the users right here, and down to the condensate recovery system. What this is gives you a one diagram with all the components of the steam and condensate system. Easy to understand, easy to read, and easy to explain to management program. The steam performance balancing provides a safety knowledge, understanding where the safety valves sit in the system. A steam system operating at 120 psi, what are the safety valves set pressures? So if I'm putting a component into a 120 psi system, I need to know what the safety valve is set for. Possibly 150 psi, 366 degrees. So everything I put into the system must be rated for that. The other thing with the steam performance balancing is reliability, understanding the critical operation of the system. Example is a steam turbine bypass valve, which is a high pressure drop valve. I want to know where it's located into the system and how reliable it is. The steam performance balancing diagram provides us that information. The other thing is optimization. What is the most efficient operation of the steam generating units? So if I have several generating units here, and cogeneration here and cogeneration here, what are the most efficient units that I should be operating? Number one, maybe here. Maybe this is number two, and maybe this is number three. But it gives us understanding of the optimization. The other thing with the optimization is understanding where our losses are. Are our losses down here? And how we can recover our losses. So it gives a lot of information on balancing the system out, especially for performance. Steam performance balancing knowledge is system dynamics. The other thing about allowing operators, managers, engineers to convey the system dynamics easily between groups. And training. How do we train new people on the steam and condensate system without having one print or diagram showing us the complete system? The thing with the steam performance balancing diagram is that correct steam performance balance can be very challenging of all the different dynamics in the system. So it gives us an understanding of the modulating steam loads, the variable production times, unaccountable losses, insulation and inefficiencies, turbine operation. All these dynamics can be put into the steam performance balance diagram. One of the things is that why are balances not accomplished in the system? High percentage of times the system is fragmented. Steam generation is one quadrant of the operation in the plant. Steam distribution is another. End users production is another quadrant, and then we have the condensate recovery system. One of the things, the difficult challenges that we find when we're doing this, and we do this a lot, almost weekly, in the steam performance balance diagram development. We have to go through the CAD library, which is a multiple of different P&ID prints. Different owners of the plant have different print diagrams, different engineering Firms come in, give us different directions on their system design and prints. All the above is saved to the different format. Plants do not keep the CAD prints up to date, which also causes a lot of issues. So it's gathering all this information, which can be sometimes challenging, but to put all this system together. So the steam performance balancing example, no flash recovery. This is one example of what a balance diagram was. There was no flash steam recovery, and they were using air-cooled coolers to cool down the flash steam down here in the system. And the thing is the system, the aerator was designed for 75 psi, but it was operating at 15 psi. Basically, we changed the system design and sent the condensate and the flash directly back into the deaerator. Substantial energy savings the first year. The project paid for itself in about a year and a half. But my point is, you couldn't accomplish that savings until we had a total understanding of the dynamics of the system, and this was an extremely large plant. The next thing is a food processing plant operation. Again, they were going to put in a standard deaerator. We were on job site. We changed that deaerator to a high pressure deaerator, and we were able to bring select processes directly back to the deaerator and reduce their steam consumption by over 6,000 pounds of steam per hour, which was a substantial energy reduction. The next example was this here. This started off to be a balance, and again, extremely large chemical plant. This was their steam balance, 8.5 by 11, basically hand-drawn print. And this is only one segment of the print. The print got to be roughly about 6 feet in length once we put all the equipment onto it. But from there, we were able to understand the flash losses and put in steam absorption units that capture that, add cooling capacity to the plant load, and again, achieve a significant energy reduction in performance. So, without steam performance, a low steam thermal cycle efficiency in the plant operation, energy losses, emissions, safety. I find safety issues all the time because people are not knowing or do not have the knowledge of the safety valve settings. Performance, the process, low steam quality is another one. And again, we're sitting there venting all the steam to atmosphere, heating up the ducts. So the end result of a steam performance is a better understanding of the total steam system, ability to set the roadmap for changes to improve the system, opportunities to improve the energy efficiency, opportunities to reduce emission, opportunities to increase reliability. So this is a kind of brief overview. Again, there's documentation on our website, articles we've written about this, technical papers on this. And most definitely we are available to come to your facility and help you develop a steam performance diagram for your facility and achieve reliability, optimization, and safety. So here's our contact information below, and thank you for your time today.